Hello student, how are you? I'm Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you whole circular motion chapter in one shot. This is very effective for NEET crash course. NEET student will be benefited from this class. Now student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with good rank. Now let's start about the class. So follow my class attentively. What is circular motion? When a body rotates in a circular path, that is, and suppose it makes an angle theta with horizontal line in t second. Theta is called angular position. So angular velocity, first angular velocity equal to theta by t, that is angular position by time. So theta equal to omega t. Now omega is actually vector quantity whose direction is along the direction of theta. Here theta is angular position which is also vector quantity. Now what is the direction of theta? Theta vector is along the axial vector. So angular velocity is along the axial vector. Now there are many videos on circular motion on each separate topics. If the student required, then they can watch the separate videos. Details will be discussed there. Now here I just complete circular motion with the whole chapter in one shot with important problems. Now students will get the important theory in important topics for NEET. This is the best effective NEET crash course. So here theta equal to omega t, and omega is a vector quantity whose direction is along the direction of angular position. Unit is radian per second. Now what is rpm? rpm means rotation per minute, that is in one rotation 2 pi angle is produced, so 2 pi by 60 radian per second. Also rps 2 pi radian per second, and rph 2 pi by 3600 radian per second. Now here also two important terms, that is time period. What is time period? Time period equal to time taken to complete one rotation, which is equal to 2 pi by omega. T equal to 2 pi omega, and n equal to frequency, that is numbers of rotation in 1 second, which will be n frequency equal to 1 by t. So t equal to 1 by n. Now omega equal to 2 pi by t, which is equal to 2 pi n. So omega equal to 2 pi n, this is the important formula. T equal to 2 pi by omega, these are the important formula. Now actual, what is the relation between velocity and omega? Now if the distance traveled is s, and the body rotates with uniform circular motion, whose speed is constant, v equal to speed, that is magnitude of the velocity, equal to v. Here uniform velocity means the magnitude of the velocity remains same, the direction of the velocity changes at every point. So velocity is not constant, but magnitude of the velocity is constant, which is called speed, v equal to speed. So if if r is the radius, then what is the relation? S equal to r into theta. Now speed equal to distance by time, so r into theta by t, that is v equal to r omega. So this is the relation for circular motion, but actual in vector form this will be v equal to omega cross r, v equal to omega cross r. In actual, v equal to omega cross r. Linear motion and circular motion. So study the circular motion, equation of circular motion. Study by comparing the equation of linear motion. Suppose v equal to v equal to u plus at. So here equation is omega t equal to omega 1 plus alpha into t. So first here alpha equal to angular acceleration. So what is the angular acceleration? Angular acceleration is denoted by alpha, which is equal to rate of change of angular velocity, omega 2 minus omega 1 by t. and omega 2 and omega 1 has same direction, which is along the direction of axial vector. So alpha equal to this, and omega 2 equal to actually v2 by r minus v1 by r by t, which is equal to v2 minus v1 by t into 1 by r, which is equal to v2 minus v1 by t is a by r linear acceleration. So a equal to r into alpha. So a equal to r into alpha. This is the relation. V equal to r omega, a equal to r alpha. So this is the relation. So so memorize this with the by comparing this formula. V equal to plus at in circular motion. This equation is this. So b square equal to u square plus 2s. The corresponding equation will be omega 2 square equal to omega 1 square plus 2a. A is alpha and s is denoted by theta. S is replaced by theta, and s equal to ut plus half at square. So s is replaced by theta. Theta equal to omega 1 t plus half alpha into t square. Now s nth means distance traveled in n second, which is equal to ut u plus a by 2t minus 1. This is theta n equal to omega 1 plus alpha by 2n minus 1. So here n we denoted n. That is this is the distance travel in last 1 second if the particles travels for n second, and this is the angular distance, the change of angular position or angular displacement in last 1 second if the particle rotates for n second. So compare this equation. So these are the equation of circular motion. You can remember this by comparing this motion in kinematics. That is, you can memorize this formula by comparing this equation and centripetal, tangential and angular acceleration. So what is, if a body, this is a rod and a stone is tied by string and rotating in a circle, this circle. So first centripetal acceleration is towards the center. Centripetal acceleration, the string is always being pulled towards the center. The string is always being pulled towards the center. So the body rotates. So acceleration towards the center is centripetal acceleration. Now if we multiply mass by acceleration, then we get the force. So in this direction centripetal force is produced. Now when the centripetal force, when the body rotates with omega, then centrifugal force is produced. Centrifugal force is developed, which act towards the radially outward. Now when the body rotates, then a force act on the, for which if the rod is loosely held, then it can, Fc is equal to centripetal force Fg equal to centrifugal force and Fr equal to centrifugal reaction. Now Fc equal to Fg equal to Fr, which is equal to value m omega square r. R is the radius of the circle. So first centripetal force is required to rotate the body. First centripetal force is required for rotating the body. When the body rotates, then centrifugal force is developed, and after this a centrifugal reaction comes. So first this force is supplied, then this force and this force is produced. The three force has the same value, which is m omega square r, or v equal to omega r. Now put omega equal to v by r, we get mv square by r. So now the tension of the string, if we calculate tension of the string, then we get m omega square r or mv square by r, which is tension of the string. For uniform circular motion, what is the tangential acceleration and what is the normal acceleration, an ac normal or centripetal acceleration, same things. For uniform circular motion, that is the body rotates with uniform speed, the body rotates with constant speed, that is for constant speed at equal to 0, and an or ac has the value of omega square r or v square by r. So the every circular motion has an acceleration. It may be uniform or non-uniform. So if the body has a uniform circular motion, then only acceleration is centripetal acceleration. Only acceleration is centripetal acceleration. Now centripetal force equal to mass into acceleration, which is m v square by r. Now for non-uniform circular motion, what happens? For non-uniform circular motion, for non-uniform circular motion, at not equal to 0, tangential acceleration not equal to 0, at has some value. So for non-uniform circular motion, at act in this direction and an act in this direction, an or ac, an angle between at and an equal to 90 degree. So net acceleration is along this direction. So for non-uniform circular motion, what is the acceleration? Acceleration equal to at square plus an square, at square plus n square. Now what is at? At as non-uniform, so here velocity changes, and suppose velocity is the function of t, so dv by dt equal to at. So tangential acceleration will be actually dv by dt. So put here dv by dt whole square plus n normal acceleration, which is equal to v. Suppose at a moment you have to calculate the acceleration at a particular time. So at that time find v, put t equal to here, so you get the instantaneous velocity. So that velocity v square by r equal to normal acceleration, which is equal to this. So a equal to, for non-uniform circular motion acceleration, the value will be this. This is very important theory for NEET. And the acceleration is along this direction. Now if this angle is alpha, what is the value of alpha with vertical? So that is at which direction acceleration acts. This we get from the triangle tan alpha equal to this perpendicular by base, that is an by at. Now an equal to v square by r and at equal to dv by dt. So from this relation we get alpha. Now what is the velocity of a body, velocity of a rotating body in circular path of radius suppose 10 meter. Rotating body in circular path of radius 10 meter varies with time as v equal to t square. Suppose velocity varies according to this, v equal to t square. Find the acceleration of particle after 2 seconds. So this is the question. And what is the angle? Angle between velocity and acceleration of the particle. What is the find the acceleration of particle after 2 seconds, and what is the angle between velocity and acceleration of the particle. So this is the question. So to solve this problem, find the formula is acceleration equal to dv by dt whole square plus v square by r whole square. This is the formula. So first, from v equal to t square we get dv by dt, which is equal to 2t. So dv by dt at t equal to 2 seconds. Find the acceleration after 2 seconds. So time equal to giving 2 seconds. At t equal to 2, this is 4, and velocity at t equal to 2 square, which is equal to 4. So what is the acceleration? Acceleration will be, now put this dv dt equal to 4 square and v square V is 4, so V square equal to 16, V square by R equal to 10, R equal to 10 whole square. So this is the answer. So this is the answer. Okay, now what is the angle? For angle we get 10. What is the direction of the question is what is the angle between velocity and acceleration? So net acceleration is along this direction and velocity is always along the tangential acceleration. Velocity of the particle is always along the tangential acceleration. So this is the velocity direction of velocity and acceleration is this. So angle is alpha. So the angle between velocity and acceleration is alpha, which is so we get tan alpha equal to n by 80, that is n equal to what? Normal acceleration equal to v square by r, that is 16 by 2, 16 by r, that is 1.6, 16 by r, and 80 equal to dv by dt, which is equal to at t equal to 2 seconds, that is 4. So 16 by 4, 16 by 40. So tan alpha equal to 2 by 5, that is alpha equal to tan inverse 2 by 5. So at this angle, this is the angle between velocity and acceleration at that point. So this is the important points. And angle, if the question comes that for a non-uniform circular motion, accelerated motion, for a non-uniform accelerated motion, angle, if angle between velocity and acceleration is, if theta greater than 90 degree, this is one option. Theta less than 90 degree, theta equal to 0 degree, theta equal to 180 degree. Which one is correct? So the angle here we get that this angle is alpha, that is theta. From this figure we clearly understand that theta, this is alpha, theta is less than 90 degree. So this is the answer. From circular motion, if the body rotates, for a non-uniform circular motion, for retarding motion, if the velocity is in this direction, then the acceleration is opposite. So this is the acceleration, this is tangential acceleration, and normal acceleration is in this direction. So now net acceleration will be this and this. For the net acceleration is along this direction, net acceleration is along this direction. So this is net acceleration. For retarding motion, once again I repeat once again, if the body has a velocity in this direction, then as body retarding motion, the acceleration is along the opposite. Acceleration is opposite to the velocity, so acceleration is along this direction. This is tangential acceleration, and normal acceleration act always towards the center of the body. Normal acceleration is always towards center of the body, so net acceleration is in this direction. Now what is the angle between velocity and acceleration? Angle between velocity and acceleration is this. So theta greater than 90 degree is the answer. Now what is the value of this? If this value is 90 plus theta, if this angle is suppose theta, what is the angle, what is the theta? We get tan theta equal to 80, this is 80, tan theta equal to 80 by n, or 180 minus, if we get this angle, theta. Now what is the tan theta? Tan theta equal to perpendicular by base, that is an by 80, which is equal to v square by r by dv dt. So if this angle we get theta, then what is the angle between velocity and acceleration is 180 degree minus theta, where theta is in vertical plane. Suppose here a stone is tied by string, and it rotates in a circular path in vertical plane. That vertical plane is up and down, up to down. So what is the tension at different position? A, B, C, D. Now if the So now if this angle is theta, what is the tension? Tension is this direction, tension act in this direction, weight act in this direction, and if the velocity at here vb, then centrifugal force mvb square r act in this direction. Here l is the length of the string, so centrifugal force act in this direction. Now what is the tension at theta? Tension, so tension at theta equal to m g cos theta plus m v b square by l. This is the tension at theta or tension at b. Suppose tension at b, tension at point b equal to this, because if this angle is theta, then this is theta, so mg cos theta act in this direction, mg cos theta act in this direction. So tension at b equal to this. Now to get the tension at a, we get just theta equal to, put theta equal to 0 degree. If theta equal to 0 degree, we get tension at a, which is equal to mg cos 0 degree plus m v square by l, that is mg plus m v square by l. Now for tension at c, we get, if we put theta equal to 90 degree, so theta equal to 0 is for tension at, we get tension at a. If theta equal to 90 degree, we get tension at c, which is equal to cos 90 0, so m v square by l. Now for tension at d, theta equal to 180 degree, so tension at d equal to cos 180, value is minus, so m vd square l minus mg. So this is the tension at d. Now we find that tension is minimum at d point, and tension is maximum at a point. So ta is maximum value and td is minimum value. So note that formula. Tension maximum is at a point, which is equal to m this, and tension will be minimum at this point. Now next, what is the condition for complete rotation? Now condition for complete rotation. Condition for complete rotation. Condition for complete rotation: minimum velocity. Find minimum velocity at A and at B. So find the minimum velocity required at A and D. So if such that the particle rotates in one complete rotation. So for complete rotation, the particle reaches at the point D, such that reaches at the point D, and tension is 0. If the tension is 0, the tension should be greater than equal to 0. For complete rotation. And for minimum such that TD minimum must be 0. If TD less than 0, then the string slacks and it falls down, so the stone cannot rotate. So for complete rotation, TD minimum will be 0. Now what is the tension at D? Tension D was m vd square by L minus mg, which is equal to 0. So from that we get Vd equal to root over L into g. So this is the minimum velocity at D point. Now to get the velocity at A point, we have to remember that change of kinetic, that is change of kinetic energy equal to change of potential energy. So half change of kinetic energy is half m v square minus Vd square equal to change of potential energy mg into 2l, because length l, so total here height is 2l, so change of potential energy mg into 2l. Now cancel, we get v square equal to 4lg plus vd square, so 4lg plus vd square equal to lg, 5lg, so v equal to root over 5lg. This is the minimum velocity. If the velocity v greater than, if b greater than root over 5lg, then the body can easily complete the circular motion, and if v less than, so body can complete the circular motion, and if v less than root over 5 cannot complete circular motion. and this is can complete, for this velocity body can complete circular motion, and v less than this cannot complete circular motion. Now what is the tension, tension at A and D? So tension at D will be 0 and tension at A equal to, formula is mg plus m v square by L. So put mg v square equal to 5 lg, so 5 mg we get 6 mg. So this is the tension at A. Now you find that if you are asked to find the tension at C, what is the tension? To find the tension we always find, so if the velocity is this, then tension at C will be m vc square by L, which is equal to m by L vc square. What is vc? Vc square. Now to get the velocity at C, we use change of kinetic energy equal to change of potential energy. Okay, change of kinetic energy equal to change of potential energy, which is half m vc square minus 0 equal to change of potential energy equal to mg into L, that is vc square equal to 2lg. So let's use change of kinetic energy equal to change of potential energy, which is half m v square minus vc square equal to mg into L. So cancel, v square equal to 5lg minus vc square equal to 2lg. So vc square equal to 3lg. Now put here, we get tc equal to m vc square 3lg by L. L cancel, so 3mg. So tension at C equal to 3lg. Now we find the tension at any position. So for that we get the theta, the tension at any angular position. To find tension at any angular position, tension at any angular position. Suppose for this circle, suppose we have to find the tension at this angle. If the length is L and the velocity at lowest point is u, so what is the tension at that point? Here first we have to calculate the velocity. Then if we get the velocity, what is the tension? Tension is first mg cos theta plus m v square L. So tension at theta equal to mg cos theta plus m v square by L. This is the tension. Now what is the u is given? Here u is given, find velocity v. So if u is given, what is the velocity of v? To find the velocity, we calculate first height ascent. What is h? H will be h. What is h? O A B. Now h equal to actually AB, which is equal to OA minus OB. OA equal to L and OB equal to what? OB equal to L cos theta. From this triangle we get OB equal to L cos theta. So L minus L cos theta equal to H. So now the particle goes from A to this position. A to, suppose this is theta position, A to this position. So height ascent is H. So apply change of kinetic energy equal to change of potential energy. Apply this, we get half m u square minus v square equal to change of potential energy mg into height h. mg into h. What is h? H is L into 1 minus cos theta. So cancel, you get v square equal to u square. So from this we get v square equal to u square minus 2lg into 1 minus cos theta. We get this. So this is the answer. Tension at theta equal to what? Mg cos theta plus m L v square. What is v square? V square equal to this, u square minus 2lg into 1 minus cos theta. So mg cos theta plus m square by L minus m g 2mg 1 minus cos theta, which is equal to, just calculate, 2mg cos theta, 3 mg cos theta minus 2mg plus m u square by L. So this is the tension at any angle theta. So if the numericals, if the value are given, just put here, you get the result. You get the result. Okay. So always find the tension at theta, always find the velocity at that point. Now general condition is that, general formula is this: tension at any angle theta equal to this. Now u is given, so you have to find the velocity. To calculate the velocity at point first, to calculate the velocity at that point first, you find the height equal to AB equal to OA minus OB, that is L minus L cos theta. NEET student can memorize the formula H equal to, for this type of figure, height equal to always L minus L cos theta. Now to find the velocity, always use this type of equation: change of kinetic energy equal to change of potential energy, which is equal to half m u square minus v square equal to mgh. Now h equal to, put here h equal to this, we get v square. So v square, if you get v square, then if you get v square from this, then put here v square, the value of v square, put here, you get the tension at theta. This will come. So this is the procedure to find the tension at any angle theta. Is suppose this is 60 degree and length is 8 meter and mass is 2 kg. So a stone of mass 2 kg is tied by string of 8 meter, and this is pivoted and it is released from 60 degree angle. This angle is 60 degree given. So if it is released, that is equal to 0, then when the stone reaches this angle 60 degree, when this thing reaches 60 degree vertical at lowest position, what is the tension at this? What is the tension of the string at here? So for this diagram, again we find the velocity at this point, the velocity at that point. We find first velocity at that point. To find the velocity, we have to know the height, this to this height. We have to know that this height, which is equal to this height h1 and this height h2. So h equal to, first calculate height as height descent, h1 plus h2. Now what is h1? h1 equal to this, that is this equal to this is equal to 8 sine 60 degree. So 8 into sine 60 degree. Okay, because you know from this triangle sin theta equal to perpendicular, suppose this is h1 by hypotenuse is 8, so h1 equal to 8 60 degree. And h2, what is the h2? h2 equal to this. Now from this triangle cos 60 degree equal to h2 by 8. Here it is given that the string is inextensible, so the string length of the string is not increased, so length of the string remain constant, 8 meter. So h2 equal to, we get 8 cos 60 degree. So from this we get, so h equal to this. Now what is the velocity? To find the velocity, apply this theory: change of kinetic energy equal to change of potential energy, which is equal to half m v square minus 0 equal to change of potential energy mg into h. cancel, so we get v square equal to 2gh. What is h? H equal to this. Okay, 8. So v square equal to this. Now what is the tension at this? Will be mg cos theta plus m v square by l. Now m equal to 2 kg, just value. G equal to 10 cos 60 degree half plus v square equal to this by l equal to 8 meter. So this is the answer. Calculate this. So you solve this way. This is the tension. Now what is the circular motion in horizontal plane? Circular motion in horizontal plane. Circular motion in horizontal plane or conical pendulum or conical pendulum. Two topics. If the body rotates in a circular, in a horizontal plane. Suppose this is a string and this is a stone, so the stone rotates in a horizontal plane. And what is the maximum tension? Maximum tension of the string will be just m omega square r. So remember, when the string rotates in a horizontal plane, the maximum tension T maximum equal to m omega square r. So this is the answer, omega square. So if you increase the omega, then if you increase the omega, then T increases. So to find the maximum, so if it is given that T0 is the breaking point, T0 is breaking value, that is when tension, this is the maximum tension the string can withstand is the breaking value, that is T0 is the maximum tension the string can withstands means the string can tolerate up to this tension. After this tension, the string can break. So what is the angular velocity for which the string cannot break, the string cannot tear or break? So for this we get this value. So omega square equal to T0 by m into r is constant, so omega equal to this shape is concave polynomial shape. Now if the if the stone rotates in a horizontal plane in conical pendulum shape, what is the tension of the string? So what is the different equation here? If this angle is theta, then we get this angle is theta. Just find the equation, different equation. Weight act in this direction. Now the stone rotates with the stone rotates of the circle with radius r. So here omega square r is the centrifugal force, and t cos theta in this direction and t sin theta in this direction. So t cos theta balance the weight and t sin theta balance the centrifugal force. So divide, we get tan theta equal to omega square by rg. So this is the relation between omega theta and r. Now if to find the tension, we get to find the tension squaring and adding. So t square equal to this, okay. So t square equal to this, so t equal to this. So t equal to this. Now tension equal to this and tan theta equal to this. So this is the different equation in conical pendulum. Now what is the relation between r and h? What is the relation between r and h? We get tan theta equal to r by h, perpendicular r by h, this by this, and tan theta equal to omega square by rg equal to r by h. Now if so when the particle rotates in a horizontal plane and in the form of conical pendulum shape, here different force acting on the particle is weight act in this direction, centrifugal force act in this direction, t sin tension is here, the component of the tension is in the direction t cos theta because this is theta, and is in the direction t sin theta. So t sin theta balance centrifugal force which is m square, and t cos theta balance the weight. So divide, this is 1, this is 2, divide 1 by 2, we get tan theta equal to omega square r by g. Now if you are asked to find the tension, so to find the tension squaring and adding, we get t square sin square theta plus cos square theta equal to m omega square r whole square plus mg whole square. So t equal to this. Now what is the relation between h and r and omega? So from this triangle we get tan theta equal to r by h, tan theta equal to r by h, which is equal to this omega square r by g. So cancel r from both sides, we get h equal to g by omega square. So this is the answer. So if we increase the omega, then height is decreased. If omega increases, height decreases. So if omega increases, height decreases. So these are the different equation of, suppose this is a plain road, along which a car turn with a speed v. Suppose a car turn with a speed v. Now the friction coefficient is mu given. What is the maximum velocity for safe turning? What is the maximum velocity of the car for safe turning? So here centrifugal force act in this direction, which is mv square by r. If the car if the car want to turn of the circular path of radius r, then the centrifugal force is mv square by r. Now friction prevents the slipping. So due to this force, the car always these forces act outward. So due to this force, the car may be toppled, but friction prevents the outward motion. Friction prevents this motion. So friction, what is the friction? So friction should be greater than equal to mv square by r. If friction greater than this, then the car cannot topple or the car cannot move outward. So he can safely turn. He can take the turn safely. Now condition for no speeding or maximum speed we get from this relation, f equal to mu mg, which is mv square by r. So v less than equal to 2 over mu rg. So maximum velocities of for safe turn equal to this. So condition also given. If you are asked that condition for no skidding, maximum velocity for condition for no skidding, then velocity will be root over mu rg. This is the v maximum. With lower speed he can turn. Now so if mu is fixed, then r, as the value of r increases, then he can increase his speed. As r increases, velocity is increases. If mu is fixed, and if r is fixed, then r is fixed, then velocity is fixed. Path for climbing the hill, metro track, etc. This is inclined. Now this inclination, this path is banking road. So this is some not plane, but it is inclined. Now if a car take turn in this path, so what is the different force acting? Different force acting is weight act in this direction, normal direction act. What is normal direction? Normal direction is normal to the plane. This is normal direction n. Now centrifugal force act in this direction. So if you resolve n along this and this direction, so this is theta, means this angle is theta, so this angle is theta. So along this component is n cos theta and this at n sin theta. So here n cos theta balance the mg and n sin theta provides necessary centripetal force. So mv square by r. If we divide, then tan theta equal to v square by rg. That is v equal to rg tan theta. V equal to root over rg tan theta. This is theta is banking angle. So if the car moves, the plane is smooth. So if the car want to turn with velocity v of radius r, then the velocity is this velocity. Now if he want to increase his velocity, then r should be increased. That is radius will be more. If the velocity is low, then r should be low. So that is when velocity is minimum, then the car goes down. When velocity is more, then the car goes up to balance such that this equation is satisfied. Then he can take the safe turning. So when velocity is minimum, When velocity is low, the car goes down. When velocity is more, the car goes up, so that he can take the safe turning. So this is the velocity for smooth banking road. Smooth banking road. Now if there is a friction, what happens? So now banking of rough road. Now banking of rough road. When here friction, if v equal to root over rg tan theta, then friction equal to 0. Now if velocity is maximum, if velocity is greater than root over rg tan theta, what happens? Velocity is more means this force more, so the car goes up, but the friction stop this motion. So when v greater than rg tan theta, then friction act downward. This is the friction. And if v less than rg tan theta, then friction moves upward, then friction acts upward. So v greater than this, then friction act in this direction. So now what is the relation between this? If this angle is theta, this is theta, so this is f cos theta and this is f sin theta. Resolve f along two directions, this and this. Now f sin theta. Always remember that we resolve friction and normal relation along horizontal and vertical. Just remember this. We always resolve normal relation and friction. Resolve normal relation friction along horizontal and vertical. If you cannot remember the formula, so you draw the picture and resolve friction and n along horizontal and vertical. So f cos theta, now f cos theta, n cos theta, here n sin theta. So we get f cos theta plus n sin theta, balance this force mv square by r, and n cos theta, balance this force plus this force, f sin theta plus mg, m sin theta plus mg. So now if the maximum speed, if you are asked to find the maximum speed for v maximum, we can use friction equal to mu into n. If you are asked to find the maximum velocity, then you can use f equal to mu n. So f equal to mu n, put here mu into n cos theta plus n sin theta equal to mv square by r and n cos theta mu n, and n cos theta minus mu n sin theta equal to mg. This is 1, this is 2. Now if we divide 1 divided by 2, we get mu cos theta plus sin theta by cos theta minus mu sin theta equal to v square by rg. So v equal to rg of this, v equal to this. Now if we divide cos theta on numerator and denominator, we get cos theta mu plus tan theta by 1 minus mu tan theta. So this is the result. So velocity maximum, value of velocity maximum is this result. Velocity maximum is this result. V maximum equal to this. Now if mu equal to 0, we get v equal to root over rg tan theta, which is the expression when friction equal to 0. So from this we also get, if mu equal to 0, we get v equal to root over rg tan theta. Now if the friction moves upward, if the friction acts upward, just we get when the velocity is less, then weight is weight is more than this value. If velocity is less, then weight is less than this value. If the velocity is less, then this value is less than the weight, so the car tends to slip downward, but friction prevents the slipping, so friction acts in this direction. Now what is the minimum velocity for which the minimum velocity is? So when friction is act in this direction, if we resolve friction along this and this, we get if you resolve friction, this friction along this and this, so here f theta theta, f cos theta, f sin theta, f just reverse f cos theta. Now just put here mu equal to minus mu, mu equal to minus mu. So v minimum will get we root over rg into, just put here mu equal to minus mu, tan theta minus mu by 1 plus mu tan theta. So this is the result. So v maximum this and v minimum is this. Just put here mu minus mu in place of mu. So we get this result. Now if a sphere is placed and a small ball is placed on the top of the sphere, this is a sphere and a ball is placed on the sphere, and this is smooth surface. Suppose the ball is gently pushed, so the ball moves to slide along the surface of the sphere. Now at a point the ball leaves the contact of the sphere. What is the position from the ground at which the ball leaves the height? So find h so that ball leaves the surface. For this type of question, we draw the free body diagram. This is center, so normal direction act in this direction. This is theta, weight act in this direction, and component of the weight along this direction is mg cos theta. Normal direction is this mg cos theta, and also m v square by r act in this direction. So the equation is n plus mv square by r equal to mg cos theta. Now when the ball leaves the contact surface, then n equal to 0. So normally there is no normal direction. If the ball leaves the contact surface, so normal direction is 0. This is the condition. So v square equal to rg cos theta. So this is the result. Now what is the velocity? Here velocity u equal to 0. Now we apply always change of kinetic energy. To find the velocity, we always apply change of kinetic energy equal to change of potential energy, which is equal to half m v square minus 0 equal to mg into this height. Now what is this height? H equal to r minus r cos theta. So cancel m and m. So v square equal to 2rg, 1 minus cos theta. So this, now here v square equal to rg cos theta minus cos theta, so cancel rg both side. So we get 3 cos theta. From this we get 3 cos theta equal to 2 cos theta plus cos theta, 3 cos theta equal to 2. So cos theta equal to 2 by 3. So we get h equal to, what is this height? H dash equal to, actually h dash equal to 2r minus, total this height is 2r minus h. This height is actually 2r minus h. H dash from ground, h dash equal to height of the ball from the ground. So this is equal to 2r minus h. Now what is h? H equal to, we know h equal to, what is h? H equal to r minus r cos theta. Which is equal to r minus r cos theta. What is cos theta? Cos theta equal to 2 by 3. So 2r minus r by 3, that is 5r by 3. So this is the answer. So h dash, that is this, equal to 5r by 3. This height is 2r, and 2r minus h equal to h dash. So what is h dash? H equal to, from this triangle, h equal to, this is r and this is r cos theta. So r minus r cos theta equal to h. So put cos theta equal to 2 by 3. So r minus 2r by 3, 3r minus 2r, that is r by 3. 2r minus r by 3 is the answer. This is the height. Student, this is the end of the class. More important problems, very important problems for NEET exam will be discussed in another video. So student can watch this video to get such type of video and to complete the best NEET crash course theory. Subscribe my channel. Okay, thank you.